Hi, it's Mrs. Golding, and I am putting together a math video, for Friday paper 35, which is due May 7th. So I wanted to hit, first of all, number 6. This one seems to be, you know what, I think I'll do that one in class. Let's do number 5 because this one is actually a little bit easier, and then I'll do number 5 in class. So for number 6, let's get that pen right there. Sorry, number 5. Okay. So Joe has 2 shirts, 3 pants, and 4 hats. How many different outfits can he choose from? So this is like when we did before. He has shirt 1, shirt 2, pant 1, pant 2, pant 3, and hat 1, hat 2, hat 3, hat 4. And so you could do shirt 1, pant 1, hat 1. That's 1. Shirt 1, pant 1, hat 2. Shirt 1, pant 1, hat 3. Shirt 1, pant 1, hat 4. And so for the shirts, shirt 1, he has 4 options if you do shirt 1 and pant 1. If you do shirt 1, pant 2, he's going to have 4 options of that, 4 options for shirt 1, pant 3, and so on. So the way that we do this when we use the fundamental counting principle is we're just going to end up multiplying these numbers all together. So 2 times 3 is 6, times 4 is he has 24 different outfits he could choose from. Okay, so for this one, I think you guys can get this one. Construct a scatter plot that shows a negative correlation for number 7 and then a positive. Well, you know, a negative correlation is going to be not an exact line, but the data is kind of in a negative direction, and they're somewhat close together. Again, a positive, it could start at the origin or it could start above. You know, that's not part of it. But as long as those data points are going in a positive direction or a positive slope, that's what you're looking for there. Okay, not too difficult. So this one, we're looking for number 9. We're looking at the rectangular pyramid here, and we want to know how many faces. Like, those are the flat sides. So the bottom would be 1, 2, 3, 4, 5. It has 5 faces. Then how many edges? Well, there's 4 on the bottom, 5, 6, 7, 8. Okay. And then how many vertices? That's like the corners. So 1, 2, 3, 4, 5. 5 vertices. Okay. So there's 3 problems. Let's do one more. And let's go ahead and on number 11, rather than round your answer to the nearest tenth, I'd like for you to leave in terms of pi. Okay, this will make your life easier, and it'll actually end up being more accurate. So I should say precise. So the volume of the sphere is going to be 4/3 times pi times the radius cubed. And the radius we know of this sphere is 3. We have to remember our order of operations, so we're going to do our exponents. 3 times 3 is 9, times 3 is 27. So ultimately, we can multiply 4/3 pi and 27 in any order, so I can move these around, right? That's the associative property, allows me to group multiplication differently. So I'm going to look at it like 4/3 times 27 over 1. See how I'm going to multiply? So then let's do 1, and let's see. 3 goes into 27 9 times. So 9 times 4 is 36. And we haven't dealt with pi, right? It's still there. So the volume is 36 pi. We just kind of leave him out of it and then bring him in at the end. So we would have to like multiply that times a little more than 3, right? So you could kind of imagine 900-ish or more like 1200, something like that, if you were to estimate. So now surface area is 4. So surface area is 4 pi times the radius squared. Again, we're going to do 4 times pi. 3 squared is 9. 9 times 4 is 36. 36 pi. I feel like I did something wrong because I got the same answer, and I don't think I did before. Let's see what I did here. 3 times 3 is 9 times 3 is 27. Yeah. So 36 pi is also the surface area. Sure hope I did that right. Let's check my work. 4/3 pi times the radius cubed. Cube the radius 27 times 4/3. 1 and 9 times 4 is 36. Yep. And then and you know what we'll do? And this is a good thing for me to show. Let's pull up the Desmos Scientific. I know a lot of you just go straight to the calculator, but notice how this is a good example of how I want you to tackle this. So I'm kind of like unsure about my answer, so I'm going to make sure I'm plugging everything in correctly. 4/3. Let's leave out pi for right now. And then the radius was 3, and then a to the b, 3. Yeah. Right? So that's 36 pi, which is what we got because we haven't dealt with pi. Okay, so then let's go down here. And then we have, what was it again? 4 pi r squared. So 4 times radius squared is 9. So that's definitely going to be 36. So interesting that we end up with the same answer, which makes that problem kind of cool. But that's how I want to show you when you are doing your work and you get all your work done and you're like, is this right? Checking it on the calculator is a great strategy. Okay, that's 1, 2, 3, 4 problems. I think just because I just want to set these up for you. I'm probably not going to finish them. But for 18, you have 6 whole, right? 6 holes, whole things. And you're going to take away 1 4/9 of them. Well, the easiest thing that I know to do is to just make 6 holes 5 9/9. That's the same as 6. I'm just calling it something different, right? Minus 1 4/9. Now notice why I chose 9/9 instead of 8/8 or 7/7 because I want common denominators, right? So I think having it set up like this, you can finish it. Okay, and so those of you that don't have the sound on, because I know you just sometimes watch, I'm going to write it down so that you know to finish these. 1/2 plus 5/6, 3/6 plus 5/6. You can leave it improper, but make sure it's in simplest form, right? Meaning it can't be simplified. They don't have any common factors. So on this one, 7 times 1 is 7 plus 1 is 8/7 times 5/6. Okay, and I want you to try this, and I want you to finish. And then this one, 5 times 1 is 5 plus 1 is 6/5 times the reciprocal, 5/4. And I want you to go at it like that. Okay, so hopefully now that you have these started, you can finish them. And remember to simplify. Again, I'm going to write it on here in case you are not listening to me, but you're just watching. So, okay, guys, I hope that's very helpful. I want to see some Perfect Friday papers this week. I know you can do it. Have an awesome week and a great day. Remember, you're important and the world needs you. And so do I.